Greetings, folks, and welcome to My Mind's Madness. Welcome back this week for this week's T-Shooter. In this one, we are asking a question about why server 2 cannot ping server 1. Let's have a look at the lab to refresh our memories and also look at the question because we're going to approach this one slightly different from conventional troubleshooting. So to look at the lab, we have a blue network and a green network. I've added some extra notes here just to make it a little bit easier. Coming off of gig 000 on R1, we have the blue network, which is 192.168.10.0/24. On gig 001, we have the green network, which is 192.168.20.0/24. Now, the question was, why can server 2 not ping server 1? And we have 4 different answers here. And when you're in an exam, it's very important to read the answers as well, because just by reading why can this not ping, you might go off and research things and look into things, burning up precious time whilst you're actually being pointed to what some of the answers might be. So in this instance, we can already determine that firewalls on the devices are not going to be a problem. We can determine routing isn't going to be a problem because the question points us in the right directions that we need to go. So it's important to remember that when you come across a scenario like this, read the answers as well, because then it gives you an idea of what you need to rule out rather than all the other things that you need to rule in. So in this instance, there's 4 possible answers. Server 2 has the wrong IP address, the ACL direction on an interface, ACE action, and no IP address on server 1. All of these, we can look into them. The easiest ones to rule out first would be the IP addresses on these devices. So firstly, no IP address on server 1 sounds a bit ridiculous. So why don't we check that first just by going to the command prompt. So we click on our server, go to the desktop and go to the command prompt application. From there, we can just type ipconfig. And here we can see that this PC or server does have an IP address of 192.168.10.200. So we've got an IP address and we've also got a gateway, 192.168.10.0. If we look at PC1, just for clarity as well, command prompt, ipconfig. I'm all thumbs today. This has an IP address as well. It's 192.168.10.2 with a gateway of 10.1. Let's just make sure we can ping a few things just to be safe. So ping 192.168.10.200. Yeah, we can ping that. So server 1 definitely has an IP address and we can reach it. Let's just be sure, is our gateway functioning as we expect it to? Yes, it is. Now, what you might be thinking as well, let's just quickly apply some of that logic that we learned from our last video. If I can reach gig 000 on this router, I should also be able to reach gig 001. So we're just going to try that for fun. So that should be 20.1. And yes, we can reach it. So routing's all fine. We knew that anyway, but it's fun to just try these things. So now let's move on to the next element. So we've ruled out that server 1 does have an IP address. So D was definitely not an answer. So looking at server 2, command prompt again, ipconfig. This does have an IP address, 192.168.20.200. The reason why this one is potentially a bit of a red herring is there's no documentation in this question that says this is an incorrect IP address. But what we can do is we can make some good assumptions here. One, it's in the correct network. It's in the 192.168.20.0 network. It has a gateway, which is correct, the 20.1 address, and it can probably get pinged by other devices in the network. So again, we can go to PC2 here and do exactly the same thing. Command prompt, ipconfig. Yeah, so this one has 20.2. It's got a gateway, so we can probably ping 192.168.20.200, and away it goes. Absolutely fine. So both the servers have IP addresses. That is not the problem. So we have ruled out server 2 has the wrong IP. Well, there was nothing that told us that it was right or wrong in the first place. The question didn't have enough detail for us to determine that it was wrong. If it had an address like 10.1.2 and it's inside the green network, which is the 192.168.20 network, then yes, that would be correct. but it's in the right network range. There's no other detail telling us it's wrong, so that looks right to me. So we've ruled out 2 potential answers already. Now our attention is then drawn to the ACL direction or the ACE action. So it's an access control list that consists of multiple access control entries, ACEs. So ACEs is just as important a term as ACL, but you'll commonly find that people just say, oh, it's that ACL, and they use it kind of colloquially just to say that's an access control entry. But bear in mind, when it comes to an exam, ACE will get thrown at you as well. So you need to be familiar with both terms. Let's look at the router and see what's happening on it. Firstly, I think the best thing we can do is confirm that the interfaces have what we want on them. So let's do enable, and we'll do a show run, and we'll begin at interface. And this will show us all our interfaces. So here we can see interface gig 000, and it has the IP address of 192.168.10.1, and it's got 2 access control lists applied to it. We've got access group blue in, and then access group green blue out. Now, one thing that's worth remembering is the terminology here. I found it interesting that people sometimes get confused with terminology such as in, meaning going into the blue LAN or into the green LAN. So if I was coming from the green LAN, I've come into this interface gig 01, and now I'm going into the blue LAN. And a lot of people think that that's the way this works. That is not. So please get it out of your head. The idea of the in and out statements, someone once told me you should view it like the Eye of Mordor. The Eye of Mordor exists in your router, and you're watching to see if it's going in or out of Mordor, being your router. In this instance, we've got one rule, which is the blue in, which means any traffic coming from the blue network going towards the router, going into the router on this gig 00 interface, that is going to be subject to that access control list. Any traffic that is coming out, so in this case, it'll only ever really be green traffic that's gone into the router and is now wanting to egress or exit out of gig 00, going out, will have the green blue list applied to it. So we need to see what each of these is doing to see if they're actually having any bearing on our network. Now, I can actually keep going down, but I want to do something else and do a show IP access list instead. So here's our access list. It consists of 4 lines. Let's assess each one, but whoa, hang fire. One access control list. Notice here, we only have the access control list for green, blue. There's no access control list for blue in. So what happens here? Because when you have an access control list specified, but that access control list doesn't exist, this line that I've now got highlighted becomes moot. There's no point in this line existing, because rather than apply a default rule on an access control list that doesn't exist, the router will automatically say, that doesn't exist, this could be a really bad error, so let's not apply any rules at all. Now, this is a fantastic little feature that means all traffic gets through, but it's also pretty bad from a security standpoint if you think about it. So in this instance, this line is doing absolutely nothing. So that means everything is happening on this particular green to blue out rule. So let's have a look and see if it's working for us. We have an access control list that says permit TCP from any to the host of 192.168.10.200 over port 80 www. We also have an exact same line which says that's possible for 443. So if that's correct, we can test this. We can go to, say, PC2. We can pull up a browser. And now we have the browser. We can do https://192.168.10.200. And we have a web page. So we are getting through to this particular address. And let's have a look at this command again, because it's really interesting when we look at it now. If I do show IP access list again, notice the difference here on this line where we went through via HTTPS. So our access control list is working as traffic is coming from the green LAN into router 1 and then going out of gig 00, the green to blue access list is applied, and in this instance, traffic is getting through. Let's have a look at the third and fourth lines here. We've got a permit ICMP 192.168.20.200. So server 2 is being allowed to ping. This is important. And it's allowed to ping anything in the 192.168.10.0 network, but wait, 0.0.0.127 wildcard mask. This means that this is not a /24. This is a /25 in the access control list. We can ping half of the IP addresses in the blue network, but we can't ping the other half. And we can prove that. So our original network was 192.168.10.0/24. So with a /24, that means it spans from 10.0 all the way up to 192.168.10.255. So that was the entire range, which should cover every single PC in this network. Remember, this PC is the .2 address. Well, I can't even remember. Let's call it just .10 for the time being. It was very low in the range. And this one was 10.200. Okay, so our range is covered there. But our access control list specifies that this is for 192.168.10.0/25. So that's a subnet mask, if you don't know, of 255.255.255.128. Okay, where previously it would have been 255.255.255.0 up here. Yeah. So looking at this, what does this allow us to do? Well, this means that the network no longer spans that full /24 space. It spans half of it. It goes up to 10.127. So this means that this PC falls within that access control list, but this server does not. And again, let's just pull this up on the command line and we can prove it. From the server, if we go to command prompt, let's just quickly double check this IP address again. It was .2, sorry, not .10. So if I try to ping 192.168.10.200, that's the server, that fails. We get destination host unreachable. If we try to ping 10.2, we get a success. So we found what the problem is. It is the fact that there was an access control entry blocking this traffic. And again, if we go back to our router here, what we should see is we now have two things happening. We should see that there are 4 permits that have been matched because we were able to ping the .2 address, but then there was also 4 deny any's that would have been matched because we would have then gone past this and the ping between the servers would hit this rule. So let's have a look. There we go. 4 matches, 4 matches. So again, just to be clear, if we look at the answers that we had, server 2 had the wrong IP address. No, that was incorrect. It's in the 192.168.20 range. That's absolutely fine. ACL direction on an interface is not an answer here. The green to blue is pointing in the correct direction. It's pointing out of the interface, going to the blue network. So that's absolutely fine as well. No IP address on server 1. We ruled that one out. The actual answer, which no one got, or no one has got by the time of this was recorded, is ACE action. The action happening on line 30 of the green to blue ACL. Well, folks, that's the end of this video. I really enjoyed building this lab. I really enjoyed going over it with you all. I hope you enjoyed it. If you have any questions, please feel free to reach out. Any recommendations for improvements, just reach out. And one thing that I'd really like to do is I want to get you involved in my actual audio soundbite from My Mind's Madness. And the way I want to do that is, if you're able, send me a recording of you saying My Mind's Madness. Be as creative as you want with it. All the best, folks. Catch you later.